Hey folks, and welcome to our next session. For this time, we're gonna go back to the same Shiba Inu image and understand a little bit more about what each one of the nodes that we have in a network is doing and the concepts behind them. So let's dive into it. So I have Houdini open and I also have ComfyUI open. So I'm on the object context. I'm gonna go and create a Copernicus network. Dive inside, find our ComfyUI tab and put our compound graph here. Dive inside and you can see that it is an empty network. So I'm gonna grab my Shiba Inu image, drop it down here, and we got a network created for us. So I think the goal for this video is just to kind of explain what each one of these nodes is doing and give you guys a general overview of what's actually happening in this process. Um, I also prepared an additional resource, which is a glossary about these nodes. And here you can find the training tab. Let me just zoom out. The training tab is this one here. And you have some general recommendations about how to set up custom nodes, a little bit about prompting 101, what things you should consider when prompting. But also I have a ComfyUI glossary here. So I just want to talk a little bit about the checkpoint node. So if you go back to Houdini, that's the first checkpoint, that's first node in our network. Let me hit P on the keyboard to bring the parameters, and you can see here I have a checkpoint name. Let me select my stable diffusion XL, and I'm ready to rock. So what is the checkpoint? So the checkpoint is the AI model that we're gonna run. If you go back here on the glossary, is a complete model that contains all trained data needed to generate an image. And one way to think about it is a brain, but it's also the galaxy of all the different combinations of words and images. And we need to prompt to access those. Here on this node, you may find the model, the clip, and the VAE. So what are these components? So let's go back to our glossary, check it out. So the model is the core image generation component extracted from the checkpoint. Basically, it supports all the different images that exist in this model. Then we have the clip area, and the clip's job is to encode the words you create into data that the AI model can understand. So what we're doing here when we load the checkpoint is we are loading all the data necessary to run this model. We also have the VAE here, which is the variational autoencoder, which is responsible for translating image from the latent to the pixel space. We're gonna learn a little bit about that, but a lot of the checkpoints you're gonna come across, they all carry the model, the clip, and the VAE. But it's not uncommon to find checkpoints that are only carrying the model, or only carrying the clip, or only carrying the VAE. And ComfyUI will have specific load nodes for like just the model or just the clip and the VAE. And as you navigate this world of checkpoints, models, clips, and VAEs, you're gonna get more comfortable understanding which nodes are necessary when. But for this time, for the checkpoints we're using today, you gotta just remember that this checkpoint has all these components together, but that's not true for every single one. So the model is going to carry all the information of the images that it can generate. And this goes to our KSampler, which is our denoise engine. I'm going to get to it a little bit more in a few. But it goes, the model output goes into the model input of the KSampler. The next I want to talk about is the clip text encode. And this node is a node that are going to allow you to prompt positive and negative prompts. So let's go to our prompt on 101 just to get a better understanding of what are some of the good practices when prompting for these models. I think the idea here is that on your prompt, you want to have different components that can properly explain or describe a given scene. So it's important, for example, to have a subject and a setting, and which means a clear description of the main subject and its environment. In this example prompt here, a rustic wooden table in a mountain cabin with 4 ceramic mugs, the description and the subject and setting is a rustic wooden table in a mountain cabin with 4 ceramic mugs. It's also really good for you to have technical specifications like is that a photography, should look a video, should it look like 16 by 9, or anything that kind of remains to maybe the technical properties of what you want, maybe the lens that you want to try to emulate. We also have the quality indicators such as crisp details, realistic. It's also really welcome to add some atmospheric elements such as morning sunlight or steaming hot. So adjectives that can actually help the model understand what you want to create. Composition details are also welcome. Material properties. So when I'm talking about mugs, I'm explaining that I want ceramic mugs, or I could say copper mugs, and this will help guide the model to navigate to the right place I want to go. A couple other things interesting for prompting is that it's also really helpful to use put a place a couple words between parentheses, and you can place a 1.3 here right next to the word to help the model focus on specific things you want them to achieve, such as blue and yellow, or 1.3, so that's going to reinforce the chance of blue and yellow to show up. And most of the systems that we're going to experience here in ComfyUI, they will require a positive and a negative prompt. A positive prompt is things that you want to include in your scene, such as a beautiful countertop, the mugs, but you also can say the negative prompts. And this will kind of land you on different places on this galaxy. One way I like to think about AI models, that is a big galaxy of couples of images and texts. Positive prompts place you somewhere on that galaxy, and negative prompts push you further away from areas that you not really want to be. And sometimes you don't want to be close to, for example, blurry details, deformed things, unrealistic or unrealistic reflections or something else. So here in ComfyUI, we're gonna use the clip text encode node to create the prompting. And the prompt will have to be connected into, the prompt is connected to the KSampler, and the KSampler is expecting the positive and the negative prompt. So you can just kind of provide these two. And how do you find nodes with this workflow? You hit tab, and you can just start typing clip prompt, and this should give you the prompt node. Same way we can load a checkpoint, and you get the node that's necessary to load the checkpoint. So for our positive prompt, we have this text box here with the positive prompt that we want, the beautiful photo of a smiling Shiba Inu sitting in a flower pot. And here I also have the negative prompt. I don't want any text or watermark. So this is pushing us away from areas on that galaxy that contains those words. Going back here to our resource board, I also want to give you a proper understanding of what the clip component is. Basically, it's the text encoder that translates your written prompts into numerical data that the model can understand. It's like a translator that converts words, like red car, into mathematical representations that guide the image generation process. So there will be many different clip models, and I'm really happy that a lot of the clips or a lot of the checkpoints that we find online already come with a clip embedded on it. And the next one, so now we created our clip, our positive and negative prompts. I also like, for example, you can put a green color on your positive and maybe a red color on a negative. And now we go to the KSampler. And the KSampler is our denoiser machine. It's important to understand that when we are working with generative AIs, image generation generated by diffusion, and diffusion is the process of starting from a noise and through several steps, denoise a given image into a final picture. And that KSampler is responsible for that denoising process. So when we look here and we see seed, is the seed of a noise that is going to be generated. When see steps, is like how many steps that denoise process is going to take. Different models will require you to kind of have different steps. They are set and trained on different parameters. Most of the times, these models, they will have documentation supporting what are the recommended steps or CFGs for you to use, and even sampler and scheduler name. So for this model, what is recommended is for 20 steps or a little bit more, a little bit less. You can play around with these values, and also a CFG, a little higher CFG. And what is a CFG? Let's go to our glossary here. And on the KSampler, you can see here our CFG scale controls how strictly the model follows your text prompt. Higher values creating images models more closely aligned to the description, as of lower values gives more area for the AI model to be creative with it or stay around away from the prompt, which is a really interesting concept where basically you're telling, do you want how much do you want to follow my prompt? More strict or less strict? Next we have the sampler name and scheduler. So the sampler name is the denoise algorithm that's going to be used to denoise our image. There are different types of denoising, and again, usually when you access a specific model, there will be a chart indicating which algorithm should be used. So there's a whole collection of different algorithms for it to be used, and the next one is a scheduler, and basically it's telling how should that image be denoised, or what are the specific scheduling for that. So in better terms is how much basically the pace of the denoising process, how aggressive the noise is removed from each step. And you can choose different denoising scheduling. You can choose different schedulers for your denoise, but again, usually models will have a chart telling you what is recommended. So for this specific model that we are using, this is one of the recommendations for that. As the image gets denoised, usually from the KSampler, we want the denoise to be set to 1, so you want a fully denoised image. But sometimes there will be workflows such as latent upscaling or upscaling workflows that will require you to not go full denoised. But for most of what we're going to do today, for all that we're going to do today, we're going to denoise at 1. So we saw that we are grabbing on the KSampler. We just understood a little bit more the parameters that exist here. If you ever want to understand a bit more, you can always come back to this set of this initial glossary for the Comfy. And we need to connect a couple things to it. So we connected the model, we connected the positive and negative prompts, and the last one is our latent image. So to do that, we're going to need an empty latent image node. And here we are saying the size of the image that we want to generate. And the way you can kind of understand this node is basically it creates the noise. It creates a noise of a given size that can be used for the KSampler to denoise. And the KSampler will follow these settings to denoise a given image. So that's what we need. So once the image gets denoised, it is the noise on the latent space. And that's what it makes these models so fast, is that they are not processing images on pixel space, they are processing images on the latent space. And the latent space is a moment where images are compressed and they have characteristics and information about text and image on the same space. And this latent representation needs to be decoded. It needs to be unzipped or unpacked into the pixel space. So the node that is responsible for that is the VAE decode. You can see that there are no parameters, but it's expecting 2 inputs. It's expecting the data generated from the KSampler, the latent data, and also the VAE that is responsible for decoding that. So if we go here in our glossary, I also have instructions or some commentary about the VAE. It's a component that converts between the model internal mathematical representation to actual viewable images from latent space to pixel space. And it's a decoder. And we also have a VAE encoder we're going to take a look later on. But it's important for you to consider that different models or different checkpoints might require different VAEs. For our scenario today, this checkpoint has all the information it needs on the same file. So the VAE decode will get our latent and our VAE, and it's going to decode to pixel space, and that's going to be accessible for us on the output. So maybe let's go here in our KSampler, change the seed a little bit, and hit, maybe let's just even go here and do a graph preview. Connect our latent decodes to this guy here. And let's maybe press space 3 so we can look at this image from the front. And let's generate preview. So this image gets sent to ComfyUI. ComfyUI is rendering the image, loading it to disk, and we get a different image. Couple considerations. Different models might have different requirements. For this model, it's okay for us to start at 1K by 1K. I highly recommend you playing with these models and parameters to see the effect. So maybe, for example, we can go maybe do one step, and we want the seed to be fixed at this point. So let's generate a new preview. So that one step, we have a really noisy image. They didn't have enough time to denoise the latent. The latent. Maybe let's go 5 steps. Generate another preview. So we can start seeing the image. We can go 10 steps. And generate another preview. And we can see that we already are getting like a better image at 10 steps. If we go to 20 steps, let's see what we're gonna get. Oh, a much better image. So the idea here is that the more time the KSampler has to denoise the image, the better image you're gonna have. So more steps usually lead to better quality images, but there's always a threshold or a limit. If I maybe do maybe 50 here, there's no guarantee this will actually be that much better than 20 steps. It all goes by of how that model was trained and what is expecting to generate. Sometimes if you overdo these parameters, they won't get you the right image. So it's always good for you to be highly conscious about these and use the model sheet to actually understand how it's going. We also can maybe change the CFG maybe to a lower scale of 2, just so you can see how it might not give us exactly what we are prompting for. Let's see if we're still at least going to get a flower pot. Yeah, we got a flower pot, but in a different context. So it had a little bit more freedom to think about what is necessary. And I think this will be much more interesting to see when we start doing diffusion rendering, which is one of the topics for one of the next videos. So I think we did a good run on explaining the small components that this network contains and some of the concepts behind it. See you on the next video.